Hello guys, let's talk about the uh, homework 8 or project 3. As this time you will try to use the multiprocessor, I mean more than one processors in this task. And it can be a teamwork. You can have at most 3 team member in a team, okay? And for the template I show, you need to show your team members informations, right? The name, the GWID, and the task assignment. I mean, which one do which job, right? For example, I'm Ziyuan Yang, will do task 1 and 2. So yeah, that is the assignment for each member. And I will recommend that each one will do 2 tasks, and the tasks should be 1 and 2 and 3, 4 and 5, 6, because task 2 are based on task 1, and task 4 based on task 3, task 6 based on task 5. So yeah, if you are 3 member in a group, then that's ideally really good. But if you have only 2 member, I think maybe you should help each other, because like if one is doing 1 2 3, other is doing 4 5 6, then the 3 and 4 should like cooperate each other. Okay, after doing 3, then some question in 4 can be answered. So yeah, if you just have 2 member in a group, then please assign your task effectively and help each other. Okay, and here's the data for some calculation you may need to use. The references, it will be 100K in from task 1 to task 4 to task 4. That means task 1, task 2, task 3 to task 4. Okay, and the references for task 5 and 6, it shows like here, because we are using some other data. I'm not sure will I give you the support data, but it's the first version of this video. So yeah, you just need to know these 2 things, right? 2 different references you may need to know to do the calculation. Okay, so let's just try to start with from the task 1. Okay, yeah, processor will be SMP, and remember here the number of processors will be 4, and using the MESI and LRU bus arbitration. Okay, and then for the main memory configuration, word wide will be 16, word by block is 32. Good. And you can double check that block size is 64. Block size 64. Good. Blocks in main memory will be this thing. Yeah, that is actually the default. So you can double check the main memory size will be 32 MB. Yes. Just let everything in default. Okay. And the mapping will be set associative. Good. And cache set, cache set, and the blocks in cache will be modified. I mean the cache set, the blocks in cache will modified from I think 8 to 2048. And one thing you need to remember that you need to maintain the 4-way set associative. What is a 4-way set? That is I give you the formula, the number of ways here should be 4, right? And you should do the calculation, the number of blocks in cache divided by the number of cache set. So we can check here, is it a 4-way? The blocks in cache divided by the cache set. I think yes, it is a 4-way. But since we initially we will change the blocks in cache start from 8, so let's start from 8. Blocks in cache will be 8. Number of blocks in cache is 8. So how many set we should have, cache set we should have to maintain a 4-way? Yeah, that should be 2, right? 8 divided by 2 then give us 4, so it will be a 4-way. And remember the placement is LRU, that's default. So okay, here is the cache setting, cache configuration, and let's go to the file we want to use. Initially you should see some the folder like this, right? And we should choose traces, and at this time we are not using the PRG, we are using the SPR, another data set. And when we click the line, we should use all these four divided in each four one by one. So let's use the FFT firstly, and you can see it is already setting the number of processors to be 4, and the number of memory access will be 100K, right? Just like the table set here. So yeah, the other data reading writing, you can use it, or I mean the instructions, maybe you will need to use it to do the calculation. Just be aware of this kind of data. Okay, and then we want to see the evolution, right? So at this time we are using the multi-processors because we are using more than one processors. If you are using the cache, you will just capture only one of the multi-processors. Like you can just see the result from processor 1 instead of processor 1, 2, 3, 4. Okay, so please use the multi-processors. And yeah, I still prefer the text. Yeah, and here if you can see the bus has 4 caches, then you're in a good preview. And this time we will, let's see what we want to get. I will give you the table. You may need to record something, right? The result table will be the miss rate. Yeah, you can get a miss rate from the hit and miss, right? And after answer the question, you may need to also record this the task 2 thing, right? The block transfer. So where is the block transfers and the bus transaction? That is from the bus. You will get the block transfers and bus transactions from the here. Okay, let's just start run it completely. And as you can see, the data here may take you some time to run it. I think it will be longer than project 1 homework 4, so please start as early as you can. And yeah, you can see the bus read and write something here, and the block transfers is what we want for the even task. I mean task 2, task 4, task 6. So actually, remember here is multiplied by 64 to get the data transfer traffic. So here is the origin data. You need to multiply 64 by it to get the data inside this table. Okay, so maybe you want to create some other tables to record the initial data. Maybe you want it. Okay, so please do task 1 and task 2 together, because if you're finishing the task 1 and then you can see, oh, I still need to do this. Oops. Still need to do this kind of configuration, this kind of experiment again, but they are actually the same thing. When you run one time the configuration, the experiment, you can get both hit and miss and also the block transfers and bus transactions. So I mean, when you're running one time the experiment, you can finish both 2 tables. I mean actually more tables. Yeah, 3 tables, right? 1, 2, the miss rate, the data traffic, the address traffic, and you need to do the calculation to get the bus traffic per memory access, right? Just add the previous 2 tables together and then divide it by the references. Remember what the reference is for the task 1 to task 4? It's 100K. Okay, so you can get this table. It is for the calculation thing for this the 4th table. But the 1, 2, 3, the first, the hit and miss, I mean actually just the miss rate. The second, the block transfer multiplied by 64 to get the data traffic, and the third, the address traffic you should get it. You should get this 3 table result with only one time experiment, right? Because right, like here, I'm finished the first running, and I can get it's FFT, right? And the HMS for the initial blocks in cage should be 9.062. Why I cannot modify it? Well, I don't know why I can't modify it, but you should know that you should record the result for the miss rate, and also you may need to record the result for the bus traffic. I mean the block transfers here, and also the bus transaction here, right? I remember to multiply corresponding the data. I mean the value 64 and 6. Okay, so please do 2 tasks at one time. That will save you some time. And that's the same thing for the task 3 and task 4, I think, right? Here is the miss rate, and here is the bus traffic. Yeah. Since it is only the bus traffic, so you may also want to create 2 more tables to record the block transfers and bus transactions. But actually, if you just show the bus traffic per memory access, that's okay. I mean, you just finish this table, that's fine. Yeah, so please do task 3 and 4 together. Yeah, I mean, you will record the data together in one experiment runtime. And task 5 and 6, we are also doing the same thing, nearly the same thing, right? Here is the try different processors. There's not only 4, right? We will try 1, 2, 4, 8, and here we'll record the miss rate, and here I think I will give you the bus traffic and the block transfers. But if I won't give you, then you need to record it by yourself, and it will take you much more time, like nearly 10 hours. I'm not sure, but I think I should provide the data for you. Okay, so yeah, for the calculation things, yeah, the bus traffic per memory access, actually, if I give you the address traffic and the data traffic, then you add them together and divide it by what? The table 2. The table 2 is actually what I want to say is this one, right? Remember, for task 5 and 6, the reference for the calculation should be this kind of things, not the 100K. That's different from task 1 to task 4. And okay, when you're doing the Q&A, there's also another big thing in question 4, I think. It will want you to recalculate the address bus bandwidth and the data bus bandwidth. So please also fill in these 2 table. Yeah. And I think totally there will be 17 or 18 questions. So I think some questions will take more points, right? Because like this kind of tables should take more points than other like question 1 and 2, something like this. So for task 5 and 6, I'm not sure will I provide the result table, the bus traffic table directly or not, but please start the project 3 as fast as you can, so that can save you some time. Even though it's a teamwork, you should start early, right? Thank you, and hope you can have a nice try on it. Yeah.